This problem involves an object pulled at an angle with friction. Vic is dragging a 20 kilogram box along the ground. He is applying a force of 125 newtons directed at an angle 37 degrees above the horizontal. If the friction coefficient between the box and the ground is 0.6, what is the acceleration of the box? So let's start by drawing a free body diagram. Our box. The forces acting on it are, we have Vic's force, I'll call FA, of 125 newtons. We have the gravitational force between the box and the earth. We have a normal force between the surface and the box, and we have a friction force between the surface and the box. Now, what's tricky about this problem is that our applied force here is acting at an angle. And if I choose my directions I want to use, I might choose my direction of motion is to the right. So I might choose to the right as my positive x and up as my positive y. And my applied force is in neither direction. So what I have to do is use a piece of vector math and break my applied force into what we call components. Because I can really say if I apply a force at an angle, I'm really pulling this box to the right and up at the same time. So I'm doing kind of two things at once by pulling it at an angle. And I can model my applied force as two forces, one acting to the right, one acting up, which I'll call FAX, for FA in the x direction, and FAY for my applied force in the y direction. And those two forces acting together have the same effect as my applied force at an angle. And the reason it's beneficial is that when I solve these problems, it's a lot easier to deal with Fax and Phi there than it is to deal with the applied force and the angle. To figure out how big Fax and Phi are, I can use some trigonometry. These three vectors here make a nice right triangle, where the applied force is the hypotenuse, Fax and Phi are the sides. So I can say that Fax is next to the angle I have here. It's going to be the applied force times the cosine of my angle, which is be 125 cosine of 37 degrees, which happens to be equal to 100 newtons. In the y direction, the y side is opposite the angle, so this will be 125 times the sine of 37 degrees, which is 75 newtons. Now at this point I can also find the weight of this block. Use the gravitational force equals m times g. We'll use the local version. This is going to be, the mass is 20 kilograms times 10 newtons per kilogram for a weight of 200 newtons. And that's about all I can do so far. I can now use my free body diagram to write some Newton's second law equations. In the x direction, I have the sum of force in the x. I'm going to be my applied force in the x or Fax minus the force of friction. This equals m times a. Now in the y direction, some of the forces in the y are going to be the normal force plus the y applied force minus the gravitational force, and this equals m times a in the y. Now I can make an assumption. I'm going to assume this block is not going to be moving up and down at all, so that means there's no acceleration up and down, or my y acceleration is 0. Now at this point, I want to check and see what I'm looking for. I'm looking for the acceleration of the box. So the acceleration of the box is over here. That means in order to find it, I need the mass, which I have. I need the FA in the x direction, which I also have. And I need the friction force, which I don't have yet. So I need to find the friction force somehow. Well, the friction force doesn't show up in my y equation at all, but there is one equation left I haven't talked about yet, and that is our model for simple friction, which says the friction force equals the coefficient of friction times the normal force. So I can use, I might be able to use this to find friction. In this case, I need the coefficient of friction, which I have is 0.6, but I need a normal force, which I don't have. But luckily, if I look at my y equation, that contains the normal force I'm looking for. I have the applied force in the y direction, and I have the object's weight. So if I kind of sketch out what I'm going to do here, I'm going to start with my y equation, use that to find the normal force. I'm then going to move to my friction equation, use this with the normal force from equation 1 to find my friction force, and then move on to my sum of the forces in the x equation, use my friction force along with everything else here to find the acceleration I'm looking for. So now it's just a little bit of math. Let's see, my normal force equals my gravitational force minus Fay, which is going to be 200 newtons minus 75. My normal force will be 125 newtons. And then use this in my friction equation. So friction will be the coefficient, which is 0.6 times 125 newtons. This gives me a friction force of 75 newtons. I can then use this back up into my x equation, and I get my applied force in x direction, so that's going to be 100 newtons minus 75 newtons equals the mass of 20 times the acceleration. Which means that my acceleration is going to be, let's see, 25 over 20, which is 1.25 meters per second squared.